The next chapter that we will understand is surface and line models. The surface and line models will be used for solving the 2D and 1D problems. So let us understand this. Surface models and line models are very easy to model and they are easy to solve. The time taken for creating the surface models or line models as compared to the solid models is lesser, and hence the number of elements generated will also be lesser, and thus the time taken for the complete analysis will be very less. Now, the surface models can be used for solving problems like plane stress problems, plane strain problems, and axisymmetric problems. And the line models can be used for solving the truss problems, beam problems, or pipe problems. Now, initially when we discussed about the introduction to CAE, we discussed about the types of elements. Now in this, we understood about what are the types of elements and what are the element shapes. So the same thing, we will just revise it again. We spoke about the 1D elements. Now 1D elements can be used in cases of trusses, beams, rods, pipes, bars, springs, okay, where the cross section of the beam or the truss could be anything depending what are the type you are selecting. When you consider 2D elements, they are also called as shell elements. Now when do we use the 2D elements? Whenever the thickness of the model is less than or equal to 1/10 of the longest dimension, we can consider the design to be 2D. Okay? And the element shapes involved are trias and quads. Okay? In 2D, we have different types of analysis like plane stress analysis, plane strain analysis, and axisymmetric analysis. Now whenever we have a plate whose thickness, that is the thickness which is in the z direction, is very small, the stresses in the z direction will be negligible or almost zero. Hence that is called as a plane stress problem. Then whenever a model has a very large length as compared to the cross section, the strain in the z direction, that is the length which is in the z direction, the strain in that direction will be very less or almost negligible. Hence we call that as a plane strain problem. And then we have, whenever we have a design or a model which is symmetric about an axis and the loads acting on the design are also symmetric, we can consider that to be an axisymmetric problem. Okay. Now let us go back to our topic. Okay, so here we are. So now that we have understood where to use and when to use surface model and line models, let us understand how to do the 2D analysis. So this is the model that we are going to use for our analysis. It is a simple bracket. You can see the dimensions over here. All the dimensions that appear on the screen are into mm. You can note down the dimensions in the book and then create the model using those dimensions. Now let us have a look at the problem description. The model is made up of a cast iron and it is a simple bracket which is subjected to a boundary condition as shown over here. All the 4 holes and on the opposite side, that means total 8 holes are fixed, and there is a force acting of 60 newtons on both the holes over here. Okay, and we are supposed to calculate the stresses induced and the deformation that will occur over here. So now let us solve this problem in Ansys Workbench. So we are going to add one static structural analysis system. The first thing that I have to do is I need to add the cast iron material. So I will come over here and I will add that material. Then we'll come back to the project window and now we will import the geometry. Either you create the geometry or you import the geometry. After that, we will enter into the geometry cell and make the necessary changes, or we can perform some geometry optimization steps. Set the unit system and then generate the model. You can see this is the simple model that we have. Now in this case, we can very clearly see that the thickness of the model is very small as compared to the longest dimension. So rather than considering this to be a 3D model, we will consider this to be a 2D model. So now using the mid surface option, we will generate the mid surfaces. But before that, I am going to delete the fillets over here. Okay. We forgot one fillet over here, so let me delete that. Okay. After this, I'm going to generate the mid surfaces. So I'll come to the mid surface option and then you can select your face pairs. Okay. You can select these faces also. Okay. Now this surface that we have generated over here, this and this can be deleted. So I will come to the body operation. I'll take the delete option and we will delete the bodies. Okay, you have to perform the body operation again. Okay, so this is the body that we have. Okay, you can see it clearly. And now after that, we will go into the model cell. So once you come to the mechanical window, first check the material of every body that we have. Okay, change it to cast iron. Then check the thickness. Okay, you can see that the thickness has already come over here. Now because we have used the mid surface option, the thickness is automatically updated. After which we will mesh the model. You can first use the default mesh settings. Okay, but if required, you can then go for proximity and curvature to refine the meshing again. Okay. And then after that, we will add our boundary condition. So as given in the PPT, we have to first fix all the 8 holes over here. So I'm going to use my control key and we will select all the 8 holes. Okay. And after that, I have to apply a force over here, which is of 60 Newton, acting in this direction. Similarly, I need one more force which is acting over here. Again, same magnitude and the same direction. Okay. And in the results, I am interested into the total deformation and the equivalent stress. Now, let us solve. So you can see over here, the maximum stresses induced is 3.7293 megapascal. Look at the area where the maximum stress is getting generated. And the total deformation is 0.0036297 millimeters. You can see the deformation. So you can very clearly see how easily we can perform the analysis using a surface model. Okay. So this is the first problem that we have taken to understand how to perform a static structural analysis on a surface model.